In this video, we are going to explore chemical equations. A chemical equation is an equation that describes a chemical change. Of course, a chemical change is a process where you have chemical bonds being broken and new chemical bonds being formed so that you form a brand new substance or substances with brand new chemical properties. In this little video here, you can see two hydrogen molecules reacting with one oxygen molecule. You're breaking chemical bonds and forming new chemical bonds and producing two water molecules. So a chemical equation, let's look at some of the parts of it. First of all, chemical equations show us the reactants. The reactants are the chemicals that we start with before the reaction occurs, and those are going to be written on the left side of the equation. So in this little chemical equation, over here you can see silver and hydrogen sulfide. Those would be our reactants. The products are the new chemicals or compounds that are going to be formed in the reaction, and those are always going to be written on the right side of the equation. And you can see those over here. We form brand new substances, silver sulfide and hydrogen. So chemical equations can also give us more information than just the reactants and products. They can also show us the states of the reactants and the states of the products. So for example, here we've added a little more detail to that chemical equation. We see that silver, our reactant silver, is a solid. The hydrogen sulfide is a gas. And the products, the silver sulfide that's produced is in the solid phase, and the hydrogen that's produced is in the gas phase. So we use SLG or AQ to represent the phase, where aqueous or AQ indicates that that substance is dissolved in water. Chemical equations can also give us some information about the reaction conditions. So here, we see that silver is reacting with hydrogen sulfide, and we have the line here that represents they react to form our product silver sulfide and hydrogen gas, and we see this little delta symbol above that. That indicates that this reaction occurred in the presence of heat, so we heated them up. So here, this would be a good example of a fairly complete chemical reaction. We have solid silver reacting with hydrogen sulfide gas in the presence of heat to produce silver sulfide solid and hydrogen gas. Now you also notice in a chemical equation several numbers. So we have small numbers that we call subscripts, like here H2S and Ag2S, and over here is another subscript. And we have coefficients like this 2, the larger number. So what do these coefficients and subscripts mean? It's very important that we understand exactly what they tell us. So first, let's look at subscripts. The subscripts describe the correct chemical formula for each compound in our chemical equation. The subscripts, basically the chemical formula, and the subscripts tell us how many atoms of each element are chemically bonded together to form that particular compound. So an example here would be H2O. Here we have a subscript, and this tells us that we have two hydrogen atoms chemically bonded to one oxygen atom. So the subscripts tell us the chemical formula for each of the compounds. Now the coefficients are the large numbers in front of each element in a chemical equation. We also call those stoichiometric coefficients. The coefficients of a balanced chemical equation, we'll describe that more in just a minute. The coefficients of a balanced chemical equation tell us the ratio that the substances react or the ratio that they are produced. So here, this tells us that two hydrogen molecules, and if there's no coefficient, we assume that it's a 1. So two hydrogen molecules will react with one oxygen molecule to produce two water molecules. So they tell us the ratio that these substances would react. So if you had 4 hydrogen molecules, you would require 2 oxygens and could produce 4 water molecules. The ratio is always the same. Now, when you have a coefficient in front of an element or a compound, it applies to all the elements in that particular compound. Let me give you an example. So for example, if you had the 4 in front of C, that would tell you that you had 4 carbon atoms. If you had a 5 in front of potassium iodide, well, that would tell you that you had 5 potassium atoms and 5 iodine atoms. So that 5 applies to all the atoms in that compound. If you had 4 in front of sulfur tetroxide, SO4, that would tell you that you had 4 sulfur atoms and 16 oxygen atoms. So one sulfur tetroxide molecule contains 4 oxygen atoms. If you had 4 of those, you would have 16 oxygen atoms. So just to kind of sum that up, because it's very important to understand the difference, if you had just one H2O, one water molecule, that tells you that you have 2 hydrogen atoms and 1 oxygen atom, so that you have 2 hydrogens and 1 oxygen present in that molecule. If you put a 2 in front of that, that means you have 2 water molecules. So you still have hydrogen, 2 hydrogens bonded to the oxygen, but you have 2 of those molecules, 2 of those units or molecules. So you have a total of 4 hydrogen atoms and 2 oxygen atoms. If you had a compound like this, H2O2, which is hydrogen peroxide, and you had one of these, so one hydrogen peroxide, H2O2, tells you that you have 2 hydrogens and 2 oxygens all bonded together to form a single hydrogen peroxide molecule. Okay? So appreciate the differences between what these coefficients and subscripts represent. So a little bit more about chemical equations. Chemical equations must obey the law of conservation of matter. So this tells us that in a chemical reaction, matter and atoms, therefore, can neither be created nor destroyed. So we could say that the number of and type of atoms that we start with in a chemical reaction must be the same number and type of atoms that we end with, or that we end up with as products. They may be bonded together differently, but the atoms, the types and number of atoms are the same. Another way to say this is that the reactants and products side of a chemical equation must have the same types of atoms, and they must have the same number of each atom on each side. So when we have a chemical equation that obeys the law of conservation of matter, we say that it is balanced. So take a look at this chemical equation. This is an incorrect chemical equation. Pause the video for just a second and see if you can see what is wrong with this chemical equation. Of course, this chemical equation shows that we have created matter. We started with calcium and oxygen atoms, and we produced calcium oxygen atoms, but we also produced a zinc atom. Well, that's impossible because that conflicts with the law of conservation of matter. So this would be an incorrect chemical equation. Pause this video and see if you can figure out what's wrong with this chemical equation. Of course, in this chemical equation, it shows that we are destroying matter. We start with hydrogen atoms and iodine atoms, and we end up with just iodine atoms. So we apparently destroyed hydrogen atoms in this process, which is not possible because, again, it violates the law of conservation of matter. So this one looks a little better, but still incorrect. Pause the video and see if you can figure out what's incorrect about this equation. In this equation, we have hydrogen atoms and iodine atoms, and we end up with hydrogen and iodine atoms, but we don't have the same number of atoms, so it's not balanced. We have 2 hydrogen atoms and 2 iodine atoms, but we only have 1 hydrogen and 1 iodine atom over here. So again, this violates the law of conservation of matter. So here, this would represent a correct chemical equation because matter is neither created nor destroyed. You can see that we have 2 sodium atoms that we start with and 2 chlorine atoms bonded together. Over here on the product side, we have two NaCl. So that, remember, the 2 applies to both atoms in the compound. So we have 2 sodium atoms and 2 chlorine atoms. They're bonded together differently, but again, that just shows that it underwent a chemical change. So this would represent a correct balanced chemical equation. So we'll explore balancing chemical equations a little more later. But be sure that you appreciate the parts of a chemical equation, what the subscripts and coefficients indicate, and how to recognize an incorrect chemical equation when you see one.